Welcome to day 5 of the Algebra Prep class, and today we're going to talk about solving systems of equations. And we are going to start with what we call substitution. So substitution of the system of equations. In other words, we're only going to talk about two equations, and we use two equations to solve for two different variables. In our case today, we're just going to stick with x and y. And we're going to use two equations to give us a solution to x and a solution to y. What that really means is that we're going to write two linear equations, and the solution is at one point where those two linear equations, if we were to graph them, where they would intersect. Okay, in other words, it is the xy solution that would work for both of those equations. And so as we start off, we're going to start with our first example. And we're going to write the equation y equals negative 2x plus 1. And then we're also going to write the equation 2x minus 2y equals 4. Now those are our two equations that we're going to start with. And if you notice, the first one's written in slope-intercept form. The second one is written in standard form. Two different ways that we can write a linear equation. When we're dealing with substitution, it's really helpful if we have one already written in slope-intercept form. If we don't, we can always change it. We can solve for y, or even we can solve for x and get one of those isolated. And you're going to understand why that's important in a second. So, because the word or the term substitution kind of identifies what we're doing, I'm going to talk in terms of substituting something in. So if both of these equations have a point, an xy point, that works for both, I should be able to intermix the two, which is exactly what we're going to do. I'm going to take this bottom equation that's written in standard form. I'm going to write it over here. But as I write it, you're going to notice something. Instead of a y, I'm actually going to substitute what y is equal to. And if you notice, I have this equation, looks an awful lot like this equation, except for when I have a y, now I have substituted in what this equation says y is equal to. If you notice, I now have only one variable, which is really what I want to get to because I can solve an equation with one variable easily. So I'm going to rewrite this while distributing my number through. So negative 2 times negative 2 is positive 4x. Negative 2 times 1 is minus 2. That equals 4. Then I'm going to combine terms. 6x minus 2 equals 4. I add my 2 to both sides. I end up with 6x is equal to 6. Divide both sides by 6. 6x equals 1. I'm going to work through that pretty quickly because I know you know how to solve equations once we get one term. So now I'm left with x is equal to 1, but I'm not finished yet. I now only have my x value for my coordinate. I want both the x and the y. So, kind of rope this off a little bit. What I'm going to do now, since I know my x is equal to 1, I can take that x and I can plug it in here, or I can plug it in there. Either one should give me the same answer. So I'm going to plug it into this top one. Y equals negative 2 times 1 plus 1. That just gives me negative 2 plus 1. And now I end up with y is equal to negative 1, which gives me my y coordinate. So now I know that at the point 1, negative 1, is where this line, if I graphed it, and this line, if I graphed it, would intersect on a coordinate graph. If I want to double check myself, I can plug this in for x and that in for y. 2 times 1 is 2. Negative 2 times negative 1 is 2. 2 plus 2 is 4. I know it works for both equations. All right, let's try that again. This case, and this time, I'm going to try this a little bit different because they're not always going to be set up exactly how we want. In some cases, we don't have something solved for a single variable yet. So what we might have to do is do an extra step in order to get it there. And if you look at this one, it's a pretty good setup, a pretty good situation. I have 6x minus 2y equals negative 12. I have x minus 6y equals negative 19. Well, if I look at this x, it has a coefficient of 1. In other words, it's an invisible 1 in front of it, which makes this really easy to use. So I'm going to go ahead and add 6y to both sides, and I'm going to convert this equation into x is equal to 6y minus 19. So now, these are my new equations. Okay? I've got my x value. I'm going to substitute it in. So I'm going to go over here to this side. I have 6. Instead of x, I have 6y minus 19. I'm plugging that in. Minus 2y equals negative 12. Hopefully that's making sense so far. This is exactly where we were last time. And so now I'm going to go ahead and bring that through by distributing. 6 times 6y gives me 36y. Minus 6 times 19, which gives me 114. Minus 2y equals negative 12. Can I combine those two terms? I end up with 34y minus 114 equals negative 12. Now I'm going to bring over my 114 to both sides. And I end up with 34y equals 102. And lo and behold, what works out really nicely is if I divide by 34, divide by 34, y is equal to 3. And since y is equal to 3, I can take that now and plug it back into either one of my equations. So I'll go ahead and go up on the top one for the fun of it. I'm going to bring that down here just so we can see the work. 6x minus 2 times 3 equals negative 12. So I have 6x minus 6 equals negative 12. I add 6. I add 6. I have 6x is equal to negative 6. Thus x, oh, I lost you there, didn't I? Thus x is equal to negative 1. If you follow back through, you would eventually get there as well. All right, so then my coordinate becomes, x always comes before y, negative 1, 3. And there's my coordinate. Hopefully that's making some sense. I know I kind of got us going in circles a little bit here, but hopefully you're able to follow along a little bit. We'll do one more. This one will kind of just work our way from left to right. See if we can get there. This one might take a little bit more of a challenge for us, because nothing's going to come out, nothing's going to be easily placed for us. This one is 8x plus 4y equals negative 20, and 6x plus 6y equals negative 18. Now, if I notice on this one, there are no variables that have a single coefficient in front of them. In other words, I'm going to have to do a little bit of work on this one. And so I can actually look at any of these and try and get a single coefficient available. And so what I'm going to do is I'm going to take this bottom one, and I'm going to go ahead and solve for x. So in order to solve for x in this bottom equation, I'm going to subtract 6y from both sides. I'm going to end up with 6x equals negative 6y minus 18. I'm going to divide by 6, divide by 6, divide by 6. And now I end up with this x is equal to negative y minus 3. So here's my two equations now that I'm going to use to substitute. So here I go. I'm going to write my original equation, but instead of x, I'm going to write down what x is equal to. So I have 8 times what x is equal to plus 4y equals negative 20. Now I'm down to just one variable again, which is really what I wanted. Good job. Negative 8y minus 24 plus 4y, just from distributing, right, equals negative 20. I can combine these. I end up with negative 4y minus 24 equals negative 20. Hopefully you're still keeping up okay. I'm going to add 24 to both sides. I end up with negative 4y equals 4. And then finally, divide by negative 4, divide by negative 4, and y equals negative 1. So I'm almost there, right? I got first step, solve one of the equations for a variable. Next step, plugged it in, got one of my variable answers. Last step, if you remember right, we're going to go and take it back into one of my equations and solve by plugging it back in. So let's go ahead and plug it back into our top equation again. This time we have 8x plus 4 times, now we know y is equal to negative 1. So 4 times negative 1 is equal to negative 20. All right. So now I end up with 8x minus 4 equals negative 20. Hopefully that's still making sense to you. Then I'm going to add 4. I end up with 8x is equal to negative 16. Divide by 8. Divide by 8. I have x equal to negative 2. Thus my solution is negative 2, negative 1. In other words, if I was to graph this equation up here and graph this equation right here, they would intersect, those two lines, those two linear equations would create lines that would intersect at the point negative 2, negative 1, okay? Which, if you know anything about your coordinate graph, negative 2, negative 1 would be right around there. And both of those would intersect right at that point. Now, I know we've gone through quite a few examples in a short amount of time, but please, the beauty of having it on video is that you can pause it, check over the work, see how you're doing, see if you can get some of the same answers and see what the flow of things as we go through. This is called substitution of a system of equations. I hope that helps, and hopefully you can get to the work and solve your own problems. Hope you have a great day. Bye.